find the sum of the arithmetic progression 14, 21, 28, and so on all the way till 168. So let's just mark the information that we can see that we can derive out of this. We've been given the arithmetic progression, so clearly the first term is 14. So I can start by saying a is equal to 14, the first term. I can also get the difference between any two consecutive terms, which is basically our common difference. I can say the common difference d is equal to 21 minus 14, 7. 28 minus 21 is also 7. So the common difference d is 7, right? And I know the last term of this entire series is 168. So I can say last term L is equal to 168, right? Okay, so I want to find the sum of this particular arithmetic progression. If you guys remember, we have two formulas to calculate the sum, right? So Sn is equal to n upon 2 2a plus n minus 1 into d. This is one formula. And the other formula is Sn is equal to n upon 2a plus l, right? So these are the two formulas we've got. And if you notice in both of these formulas, to find the sum, we need to know the value of n, right? In both of these formulas, to find the sum, we need to know the value of n, and only then we can find Sn. Here we've got a, we've got d, and we've got l, but n is unknown. So the first step in this kind of sum where n is unknown would be to first find n, and then we can use either of these formulas to find the sum of n terms, right? So now the question arises, how will we find the value of n? Okay, we've been given the last term, right? If you guys remember, the last term can also be considered as the nth term in the entire series, right? The last term of the series can be considered as the nth term, and with the help of the formula for the general term, which is Tn is equal to a plus n minus 1 into d, I'm going to first find the value of n. So I'll get the total number of terms, and then I can use either of them and solve it, right? So we can say L is equal to 168, which is also Tn, or the nth term. So therefore, I know, and so if you guys remember, Tn is equal to the formula for the general term, a plus n minus 1 into n minus 1 into d, right? So this is the formula for Tn. We know the last term, or the nth term, is 168, so we'll plug that in. 168 is equal to a, we know, is 14, plus n minus 1, n is the unknown here, which we need to find, so we'll leave it as it is, into d, we know, is 7, right? So let's rearrange the terms now. 14 plus 14 taken to the other side becomes minus 14. So 148 minus 14 is 154, which is equal to n minus 1 into, let's use a, right? N minus 1 into 7. 7 multiplication here taken to the other side is division. 154 upon 7 is 22. So 22 is equal to n minus 1. If I rearrange this equation now, I get the value of n as 23, right? So if I rearrange this, I get the value. So there are a total of 23 terms in the series, and the nth term is 168, or the nth term or the last term. Now I can find the sum of all the n terms. So by using the formula, I know that Sn, the sum of n terms, is equal to n upon 2. Let's use the a plus l formula, since we know the first term and the last term. So a plus l, right? If you want, you can also use this formula, because n, a, and d, all three are known, so I can use this as well. I'm using this because it's a bit more convenient at this moment. So therefore, I can say S23, because there are 23 terms in the series, is equal to 23 upon 2. The first term a, we know, is 14, and we know the last term L is 168. 168. Oh, sorry. Okay, so let's solve this now to find the value of the sum of 23 terms. So this becomes 23 into 14 plus 168 is 182. So 23 upon 2, sorry, don't forget the 2 down here. So I can cancel this term here. I can say, let's see, 2 ones are, sorry, 2 ones are, and 2 91s are. Okay. all of this equal to 23 into 91. Let's perform that calculation in a rough work over here. Let's see. 3 ones are 3, 3 nines are 27, 2 ones are 2, 2 nines are 18. So 3, 9, 10, 2. So the sum of 23 terms of this arithmetic progression is basically 2093. All right. So the question was find the sum of the AP. My answer will be, therefore, the sum of the arithmetic progression is 2093. This is my final answer in the rectangle.